this first slide, the day after Dan Kyan was here, he sent me an email and he asked me, all right. He asked me if I couldn't fill in some things that he said he thought he either had wrong or he had forgotten. So maximum sea level drop at the end of the last glaciation, 120 meters, 394 feet, and then the amount of potential sea level rise if Greenland, if all of the ice on Greenland that's on land were to melt, sea level would go up by 23 feet. If the West Antarctic ice on land were to melt, it would go up 20 feet. And if all of Antarctica, including the peninsula, West Antarctic ice sheet, were to melt, 200 feet. Now, the numbers I'm going to give you are going to be a little bit different from his. And I think mine are right. He thinks his are right. No, I think the point is there is uncertainty in a lot of this. But the uncertainty has gotten, it really has been dampened. So as we go through this, tonight, I want us to try to get our arms around some of these. Let me go back just one more second. The other thing that's really arbitrary, when we talk about the year 2100, it's the end of the century, so it's not arbitrary in that sense, but when we say sea level is going to rise 3 feet or 6 feet by 2100, if it only rises 5.5 feet by 2100, wait a little while. Because as I'm going to be talking tonight, I will point out, no matter what we do, sea level will rise for decades and probably for at least 2 centuries. If we shut off all CO2, all new greenhouse gases tomorrow, sea level would rise for decades and probably somewhere between 1 and 2 centuries because there's enough inertia in the system. And remember, once you put CO2 into the atmosphere, it stays there for about 100 years before it is then transferred to the ocean. And when it's in the ocean, on average, it stays there for about 1,000 years. So there's enough what in these systems, in physics you would say there's hysteresis in these systems. There's inertia, there's a lag, and that's important. The other thing we talked about was last week the difference between data and information. And there's a lot of confusion even in the scientific literature about the difference between data and information. I want to give you 2 people who I thought distinguished very well. Peter Drucker died a year or so ago. He was one of the great management gurus of all time. If you've never read any of his books, and if you are a manager or aspire to be one, the one I would recommend is The Effective Executive. But he wrote dozens of books. Peter Drucker said, information is data endowed with relevance and purpose. Information is data endowed with relevance and purpose. Peter Medawar, also dead. Most of the people that I know are dead. That says something about my age. Peter Medawar was an amazing biologist, Nobel laureate. He wrote a number of books for scholars. He wrote a wonderful little book about young people who wanted to become scientists. Peter Medawar said that information is data that has been configured to answer a question or to deliver a message. Data are numbers. Information is synthesis, the interpretation, the analysis of data in a way that gives it purpose, relevance, or answers a question, or delivers a message. Anybody have any questions about data? Data is one of the two words in the English language that is among the most misused words. And the word data, even the New York Times. This, you probably, I hope you can read it. This data isn't dull. It improves lives. What's wrong with that? This is even the New York Times. Huh? The word data is always plural. The singular of data is datum. And when you think, this was in the New York Times, March 12th, so not very long ago. And I thought, I drew a big red circle on it. I was going to write to the editor. I know it's not working. But it should say, these data aren't dull. They improve lives. It is, I would say it's wrong more than it's right, even by people who are really smart, well-educated people. So if you don't learn anything in this course, the other word that is misused is the word unique. People say, this guy, you're a relatively unique guy. You're a very unique guy. There's no such thing as very unique, relatively unique, sort of unique, kind of unique. You're either unique or you're not. You can be relatively unusual, kind of unusual, sort of unusual, but there's only one unique, one of a kind. So the two things I want you to learn in this course are data and unique. All right. Wicked problem, I want us to just refresh your memory on this. Wicked problems, remember, are problems that cross all disciplines, all domains. They can't be solved. They can only be managed. And as was pointed out by Dan last time, if you have policies like climate change, you can put in practice the good policies and adhere to those, but you'll never see the results for decades. That's one of the problems of a wicked problem. If you're a courageous decision maker, you can make a decision that's very unpopular, and it'll go on year after year. You won't see any of the benefits, and so people get very upset with you. And that's the trouble with wicked problems. The other thing is, with wicked problems is it's very tempting to choose one element of a wicked problem and solve it. And what you can't, since you can't solve it, it's much better to try to surround it and state it in the richest possible way. So what you want to do really is to get smart people with different perspectives and stay with it long enough to get a formulation so that you are attacking the right issue. And if you're a policymaker, an inelegant, incomplete solution to the right problem is always better than an elegant, complete solution to the wrong problem. In government, often we ask the wrong questions, and so we come up with elegant solutions, but to the wrong problems. This is often the case in the environment. Bob Grove. Bob works for an electric utility. We have in electric utilities, often power plants are sited on large bodies of water, whether they're lakes or the ocean or rivers, because in order to make a plant function, you have to cool the condensers to keep the cycle going. And if you're on a large body of water, it's the cheapest, easiest way to do it. The trouble is, when you take the water out of the ocean or the lake, you also take some small living things, phytoplankton, zooplankton, and they often get killed when they go through the plant. They either get from being heated up or more often from going through pumps and so on. So in California, we passed a law to outlaw any once-through coolant. And if somebody asks you the question, are you against killing marine life at power plants? You know, you're going to answer, of course. But that really is not the right question. The right question would have been much more complicated. Something like, if you look at the load distribution that we have in Southern California, how could we operate our power plants to have the least overall adverse impact on the environment and be economically affordable? If you look at what's going to happen, I will bet that someplace like San Onofre will have cooling towers at a cost of hundreds of millions of dollars. You're going to get your permit extended. Oh, that, no, San Onofre was a rule, you didn't have to abide, that's right. But there will be other, that's the only plant you guys own in Southern California, right? The others feed into the grid. In order to build cooling towers, it's about $200 million per plant. Some of the utilities will not be able to do it. California will end up importing more energy than we do now. It will come from Arizona in all likelihood. It will be generated by burning fossil fuel. And because it has to be transmitted long distances, you have to generate more electricity there to get the same amount here. So we're contributing, again, to climate change because of additional emission of CO2. We could have changed taken less water in, and it would have been heated up more, but you would also kill fewer organisms if you do that. Again, you have to ask the right questions. And people confuse temperature and heat, and they aren't at all the same. A plant has to reject a certain amount of heat, and it's the product of the temperature increase times the volume of water that you process. So either you use a large delta T and a smaller volume of water, or you use a small delta T and a huge volume of water. We chose to use a small delta T and a very large volume of water, which is, in some ways, if you get asked the question, if you were a zooplankton, would you rather be heated up a little bit or boiled? So we ask crazy questions.
Almost also makes a glow down there.
No. All right. The other thing, to reinforce data, information, knowledge, wisdom, action. This is a model that we developed. We've been developing it for a long, long time. This is what we use in all of our aquatic forums. And what you try to do is drive discussions up this arc, because the farther up the value chain you get, the greater the use is to managers. Managers have very little use, policymakers, for data. The last thing in the world they want is a 300-page data report. They want somebody to tell them what the information, the knowledge, the wisdom, so they can take action. University professors, if they're good, they operate down here. They only occasionally move up into this box because it's a very mean-spirited box, and it will not help you get promoted or tenured or rewarded for your efforts. This is the arena of policymakers and decision makers. And it is a mean-spirited place. So we hear the phrase that you should think out of the box. And that's good advice, but in the real world of policy making, what the challenge is to think within the box in the most creative ways that you can. You have to keep people in here. It is not something that you do in a 2-hour meeting. This is a place people live in these boxes. And that's where we have to spend more of our attention. The farther you go in this direction, the more subjective it becomes. The signal becomes stronger, the noise is greater in that direction, judgment becomes increasingly important in this direction, but the value to decision makers goes up. So it's driving the discussions up the value chain, and that's a hard thing to do, but that's where the rewards are. All right, those are the carryovers from last week. So I want to talk to you about sea level rise, and I want to give you a global overview of sea level, and then I'll make some comments about California to add to the ones that you heard last time. I'm not going to give you all of the caveats and all of the uncertainties. I'm going to give you my interpretation of an awful lot of work by an awful lot of people. And there are literally now scores and maybe even more than of sea level rise curves, and you can get totally lost in all of these. Now, this is a subject this aquarium's been quite involved in, because in December of 2009, we structured and ran and summarized a workshop for NOAA, the National Oceanic and Atmospheric Administration, and the U.S. Geological Survey. So much of what I'm going to say is based upon what we did for that particular workshop. I would not pretend that I could convince Rush Limbaugh or Glenn Beck, and I'm not going to worry about that. This was a cartoon that I had commissioned for that meeting in December of 2009, and there were a few people in the audience. Many of them were elected and appointed officials who booed quietly. But that's all right. We know that the Earth and the ocean are getting warmer. We know that the glaciers and ice sheets are melting, and we know that the addition of new water and the expansion of the upper ocean as it is heated are both causing sea level to rise. There is irrefutable evidence. Now you could say, but how do you know humans have a role in that? And we'll come to that. You can't argue with the fact that the Earth is getting warmer and sea level is rising. But this is nothing new. I think Dan showed a slide very similar to this. This is thousands of years ago, the end of the last glacial, and you can see the rapid rise in sea level up to about 8,000 years ago or so. It's been relatively flat for the last 2,000 or 3,000 years, and now it has taken off. Remember, this is when humans started over here 100 to 200,000 years ago. It took all the way up until the time of the Civil War before we got the first 1 billion people. So it took almost all of that 100 or 200,000 years to get the first billion. We got the second billion in 100 years, not 100,000, in 100, and we've been adding a billion about every 14 or 15 years. Agriculture started here. So sea level was still rising, but population 10,000 years ago was a few 100 million people, if that. Remember, it was during this period when sea level wasn't changing much, that's when civilization really took hold. So we have not been used to a rapidly rising sea. And back here, there were few people. They were hunters and gatherers. Didn't really matter much if sea level rose because they didn't have much to move. So it was pretty easy for them. And as the sea goes vertically, the sea advances laterally. And it depends upon the topography, that is the relief, the shape of the coastline, but in many areas, for every foot it goes up, it advances laterally 100 or 1,000 feet. Now, if you've got cliffs, that's not true, but if it's flat, like along the Gulf Coast or parts of the East Coast, so it goes up and it advances much more rapidly. And this is a longer period of time. Now, in the last one, the present was over here, now it's over here. The only thing and so this is 542 million years ago, and these are two different renditions of sea level rise. So assume that the real is somewhere between, and you can see that sea level has been going up and down for hundreds of millions of years and beyond that. And sea level has been lower than it was at the end of the last ice age, and it has been higher than it is today. So it's been lower and it has been higher. And for people who are doubters about climate change, they point to the fact that so it has been lower and higher. All right. But what's different now, though, is that we've got 50% of 6.9 billion people living near the ocean. And we have made these huge, huge investments in houses, schools, churches, aquariums. Ports, airports, highways, railways, all of the infrastructure to support these big cities. And that's what's different. It's not like picking up your tent and moving. We've now got a real challenge. And here is Bob's favorite power plant. What? Here's one storm. This was September 9th, 2008, and this was 6 days later. And you can see that the nice green grass and everything undisturbed. 6 days later, mud has gone through this one. Most of this island was overtopped. So the sea can do an awful lot in a short period of time.
Is that Galveston?
I don't know if that's Galveston Island or not. It's down on the Gulf, though, and it could be Galveston Island.
Representative.
Yes, it's representative of that area. So my best interpretation of the data are that by the end of this century, global sea level will rise by 3 to 7 feet, and it could be much higher depending upon what happens to Greenland. And I think Dan had, 3 and 6 feet? And if it doesn't happen in 2100, it'll be 2125 or something. But I think there's no question that sea level is going to rise somewhere in this range. Even now, the IPCC, the Intergovernmental Panel on Climate Change, they have revised their estimates. And the latest report was that they couldn't identify any scientist who was predicting less than 3. And most have it put it higher. Some areas it'll be a lot more. If you go to the Gulf of Mexico, the sea level rise there, now these are global, but if you look in any particular area, you have to look at regional sea level rise, and the whole Gulf is settling. So if you live in New Orleans or anywhere along the Gulf, the apparent sea level rise will be many times this. It'll be 2 to 3 times this. The reason we have a lot of oil there, though, is because it has been subsided. What you do is you add plant material, phytoplankton. It gets buried and then under high pressure and high temperature, gets gradually converted into oil. So you look for these areas where there were deltas, and that's where the oil is throughout the world, whether it's in the Mississippi or the Niger or other deltas. So there will be also areas where it will be less. Now, and there, as I say, there will be large regional differences. So there are places in Alaska, not all of Alaska, but there are places in Alaska that as the ice melts, you remove that load from the crust, and the crust rebounds, so the land is moving up. And if you're living along the coast in some parts of Alaska, you look out and you say sea level is going down because the land is rising more rapidly than the sea. So you have to distinguish between global sea level, what is called eustatic sea level, and regional or local, which is called isostatic, adjustments of the Earth's crust. Just remember global and local, and if you only remember data and unique, I'll be happy. All right. So the expansion, I tried to confirm this, and I couldn't find it today. And so if somebody else can, I'd like to know. The expansion part of it, though, is the most predictable, because knowing what Greenland's going to do or Antarctica is really tough. It's not just a function of temperature. There are all other kinds of factors that are going. You can check on, you can Google. But the expansion is the more predictable part. And if all of the mountain glaciers, now remember, these are mountain glaciers. If they were all to melt, they would add about 1 foot to sea level rise. So when you think back out of this 3 to 7 feet, all of the mountain glaciers don't contribute much. Up until now, the expansion from warming has been about half of the observed sea level rise. And as you go, for the short term, expansion will be a little bit more than half, but well before the end of this century, that's when the meltwater from glaciers, not the mountain glaciers, but from the glacial ice on Greenland and Antarctica, they will become the dominant contributor to sea level rise. So the big unknown, Greenland and West Antarctica. Now, what did Dan have in that first slide? I got 24 feet. I think he had 20 feet for the West.
Yeah, 20 feet for Greenland.
Pardon?
Yeah, 20 feet for Greenland, yeah, 20 feet for West Antarctica.
So he was close on one and. All right. So there's Greenland. And Greenland, it's hard to know what is going to happen to Greenland. And there is the Antarctic, and this is the part that is melting most rapidly. And there are even data from the last few years that shows that much of the Antarctic continent has gotten cooler in the last few years. But this is the part that is much more vulnerable. All right, so as sea level rises, whether it's 3 feet or 7 feet or 20 feet, all storms or all storm surges become more destructive. Whether it's a hurricane, a typhoon, or whether it's a storm surge from a tsunami. Because now you're raising the sea and you put a storm on top of it, and so its destructive power goes up. And this is at New Orleans after Katrina. And just imagine what would have happened to New Orleans if sea level had been 3 feet, even 3 feet higher. Or imagine what would have happened in Indonesia if sea level had been 3 feet higher. In the Indonesian tsunami, about 230,000 people were killed. And I don't know what that number would have been, but the damage would have been far, far greater. This is another one of New Orleans after Katrina. And that's New Orleans after Katrina. So, and that's a shot of Katrina from the air. Now, global warming has increased the frequency and the intensity of tropical storms. You'll still find some in the literature who nobody questions it anymore for the western North Atlantic. Some people question it still for other parts of the world ocean. But most of the people are coming around to pointing out that we entered a different domain for storms since 1995. And you can see these are the typhoons down here. These are all hurricane tracks there. And it makes sense when you think about with global warming, because you're not only warming the atmosphere, you're warming the ocean. And tropical storms derive their energy from the ocean. So a warmer ocean, greater transfer of energy from the ocean to a storm. They get to be bigger, stronger, and stay together longer. In many places, we have removed wetlands and coastal vegetation, mangrove forests, and they do provide a way of dissipating some energy. Now, there are some environmental groups who said that if we hadn't destroyed the wetlands around New Orleans by drilling for oil, New Orleans never would have had the damage. That's nonsense. It would have had less damage. These dissipate some energy, but they do, and they do provide some level of protection, but they do not, they're not going to stop it. This is a wetland on the East Coast in Georgia. But we have done a good job of destroying most of our wetlands. In Southern California, we've gotten rid of about 95% of our wetlands. And if you look at freshwater wetlands in the United States, we've gotten rid of even more. But it was an official policy. Look at Florida and the Everglades, for example. The policy of the federal government was to drain the swamp, because we didn't call them wetlands. I can remember, they were swamps. They were places where mosquitoes bred. They didn't have any redeeming value, and so you should fill them, drain them, somehow get rid of them. And now we're spending billions of dollars to replumb the Everglades to reclaim them. So societal judgments change with time, just like putting our rivers here in concrete ditches. Today that might not be the thing that one would do. So the countries facing the biggest challenges, every place you see a red dot, that's a delta. And the deltas of the world are among the most vulnerable places to sea level rise and coastal inundation. So we've got the Mississippi and the Yukon, but then you can find others. The Indus, it's not building much of a delta and hasn't for quite a few years. When I was in high school, I remember writing a term paper about the Indus River. The Indus River was the 4th biggest river in the world back then. And then quite a few years later, 7 of us were asked to go to Karachi because the Indus River didn't have any water in it anymore except during the monsoon season. The Secretary of Agriculture had enough power that they took all the water out of it to grow crops, and the fisheries collapsed, and the U.S. government sent several of us, 7 of us, I guess, or 9, over to spend a week, 2 weeks in Karachi. But the deltas are the ones, the Mekong, the Ganges, the Yangtze, those are the ones that are really very vulnerable. And even at the low end, if it's 3 feet, there will be what are being referred to as environmental refugees. There will be tens of millions of environmental refugees. They will have no choice but to move. And places in the poorer parts of the world are the ones that will be most affected. Indonesia. Indonesia is a very interesting place. How many of you know that Indonesia is the largest democracy in the world? It's also has the largest Muslim population in the world. It has more than 17,000 islands, many of which, with the 3-foot rise in sea level, will be gone. And not all of them are occupied, mind you. But it will suffer big losses. NOAA had a wonderful partnership with the government of Indonesia in 2010 on ocean exploration, and it was partly for science because the Coral Triangle is in that part of the Pacific, and it's, in terms of biodiversity, it has the greatest biodiversity of any area in the world ocean. But it was also because we need some friends among democracies, and particularly democracies that have large Muslim populations. Bangladesh. 90% of Bangladesh is made up of floodplain and delta, and it is the primary river is the Meghna, M-E-G-H-N-A, and the Meghna is made up of the confluence of Asia's 2 largest rivers, the Ganges and the Brahmaputra. And this is an area where storm surges, this is where lots of typhoons moving up into this area. And in 1970 and 1991, in 1970, 500,000 people were killed, 500,000. And in 1991, 140,000 people were killed. It's an amazing area. Here you can see the kind of, it's a very different kind of delta, a bird foot kind of a delta. And here it is from with a satellite shot. It's beautiful, beautiful area. And this is all very productive cropland. So a lot of the food is grown there. And they've had, in addition to this tropical cyclones, they've had terrible flooding from the river, flooding like we're seeing right now in the Mississippi. And as I say, most of the population in Bangladesh lives down here, and there will be a number of tens of millions of them that will have to move before the end of this century. This is off Bangladesh. There are some places that can retreat to higher ground, but some places have no place to go. Kiribati, the Maldives, the Marshall Islands, Tuvalu, all of these are island nations that don't have any high ground to move to. Some of them have tried to make arrangements with other countries to move their entire populations, and they have been rebuffed. It's going to be interesting to see how we're going to deal with all of this. Now, we have at least a couple of engineers in the audience, and often engineers say, we can fix that. We can fix that. It's like the story of in the old days when if you were sentenced to the guillotine, the rule was that if you didn't lose your head, you could walk away. And they were lined up this one Saturday morning, and first person put his head in, and the guillotine stopped fraction of an inch short, got to walk away. Second person, they made an adjustment, stopped, a little closer, but it still stopped, walked away. Third person in line was an engineer. He said, I can fix this. And he fixed it, and the last that was seen was his head was rolling down the street. But there are no engineering fixes that can be applied on a countrywide basis. Now, not even the Netherlands. Holland has agreed that they're going to give up a significant fraction of the country that they reclaimed from the North Sea, and they're going to learn how to live with the ocean. So, well-off countries like the United States will have decisions to make. We're not going to abandon Manhattan, and I think we won't abandon these ports out here. We will build structures, but we're going to have to be very selective, and there will be large sections of the coastline of the country that we will have to have systematic retreat from. But poor countries don't have any choice, and the rich countries in the world are going to have to help the poor countries deal with this, particularly since many of them did not contribute very much to the problem. They got this problem because of what the more affluent countries have done. All right, these are the causes of climate change. Mostly it is the burning of fossil fuels. It accounts for about 75 to 80% of the CO2 increases in the atmosphere, 20 to 25% as a result of deforestation. But this is really the issue. And all right, there is Alaska, and this is Shishmaref. And Shishmaref is a small village, and it's being threatened, and there's Shishmaref. And the decision has been made to move the entire community inland. And the process has begun. And it's costing between $300,000 and $400,000 per person. They will move. They will all be moved. They don't want to be moved because they're going to be moved into a larger city, and their way of life, which is based upon living off of the land, fishing, hunting, it will be much harder to do that. So they're worried about losing their culture. And that's another thing that we will lose with sea level rise.
What's the population?
It's 10,000. I'll get the number. I don't remember offhand. But if you look at, we're always concerned about losing biodiversity, and we should be. But maybe we ought to worry a little bit about losing cultures, languages, dialects, because if you look across the globe, we're losing those more rapidly than we're losing biodiversity. And it's the diversity of the human species that adds so much to the quality of life and why people want to travel and go see different cultures and so on, and we're losing a lot of it. This is another shot of Shismarab, and so is that. Okay, so we have built up our coastline, and that has been really the problem. And it's a problem not only for the built environment, but it's also a problem for the natural environment. The OECD, the Organization for Economic Cooperation and Development, they have a lot of really interesting publications. Sometime when you're not doing anything, Google OECD publications and reports. They did a study that ranked the 10 most vulnerable cities in the world in terms of sea level rise, and they said we're not going to add storm surges from hurricanes, typhoons, tsunamis. This is just sea level rise all by itself. The number one most vulnerable city was Miami. Number 2, New York. Number 3, New Orleans. Osaka, Kobe. Number 4, Tokyo, 5. Amsterdam was 6. Rotterdam was 7. Nagoya was 8. Tampa, St. Pete was 9. Virginia Beach was 10. So in the world, 5 out of the top 10 most vulnerable cities to sea level rise were in the United States. So then they used the same criteria, and they looked only at the US. And of course, as you would expect, Miami is still number 1. New York was number 2, New Orleans 3, Tampa, St. Pete 4, Virginia Beach 5. Boston, now Boston makes the list, Philadelphia makes the list, San Francisco and Oakland, Los Angeles comes in 9, and Houston comes in 10. And if you look at these cities and if you said, well, what about storm surges? Which of these are more vulnerable to hurricanes or nor'easters and so on? Then this list would change somewhat. So we have a problem, and as I mentioned earlier, even if we cut off all CO2 emissions, all methane, all greenhouse gas emissions tomorrow, sea level will rise for decades and probably 1 to 2 centuries. So we not only have to mitigate. Mitigation means you reduce the cause of the problem. So you reduce the emission of greenhouse gases. We also have to adapt. Now this is in Galveston, because I took that picture. And you can see how they have built their houses. And so that when you get another storm, it goes under the house. And but there are lots of places where we're going to have to figure out what to do in our wealthy countries, because there's no easy way. And this actually is in Bangladesh, and it's something we all have to be concerned about. So it's a combination of knowing when and how to retreat and making societal decisions on what we are going to protect. And we will protect. We have to protect. So we need national, state, and local policies to develop these comprehensive strategies to deal with higher sea, more frequent, more intense storms, and we're going to have to identify critical areas, both natural and built, that we're going to protect. There's the Outer Banks. Now, Orrin Pilkey, he has been here to speak. He's been advocating ever since I've known him, which is probably at least 40 years. And he's at the he's at Duke University, and he has advocated for a long time that the Outer Banks should be abandoned. And finally, people are beginning to move off many of these areas. Who in here? Well, I know you were on the East Coast. Anybody else here from the East Coast? You? Yeah, that's right. You have the places like this, and it's always interesting because if this is the shoreline, and if you have an offshore island, and it has an inlet, you get a big storm, and often these storms will sit off the coast for a few days. And when they do, they're pumping water through this inlet, and so the water is higher within the bay than it is in the ocean. And it can be quite a bit higher. The water just keeps coming in. And then the storm moves away, and now you have the sea level inside higher than it is outside. Water likes to run downhill. It can't get out of the inlet fast enough because there's been so much water stored over a long period of days. And so you cut a new inlet. And most inlets on the East Coast are cut from the inside out rather than from the outside in. And it's a very interesting process as to how that happens. Yes?
Didn't Goki give a talk here?
Yes, he did.
And he was talking about how barrier islands are moving laterally too. They don't-
Barrier islands always move, as the sea goes up, they move toward the land.
Yeah.
Right. And if we're able to continue to roll over, as they do, eventually they get welded onto the mainland.
Yeah, I showed those pictures of the kind of summer cabins on skids that they did.
Right. Right. But it's a dynamic situation that we have. Now this was another one that I had commissioned for our talk because we had people there from, don't worry Mildred, our federal flood insurance will cover it as long as we rebuild right here. That's how the law is written. You can get your house rebuilt if you rebuild it in the same place. If you want to move it 100 yards upslope, sorry, the insurance doesn't cover that. Now, if you talk about dumb things. Now, and should we have rebuilt New Orleans right where we did? If you lived in New Orleans, probably your answer is yes, because it's a magnificent city. But the next time we have a Katrina, and we will,
This year.
maybe this year, maybe next year, and they're still building.
Well, historical New Orleans didn't suffer all that.
That-
It's like the Ninth Ward out there.
Yes, yeah, well, that's true. Not, certain parts of it didn't. So the coastal zone has always been this chaotic, high-energy environment, and it's one in which large amounts of kinetic energy from winds, waves, tides, storm surges get transformed into heat, noise, and work. And the work is moving things around. Sediment, houses, barricades, and it's a tough place. And this is, as I've said several times, this is nothing new. Throughout geologic time, this has happened. The only thing that's new is having lots of people living very near. And as we look into the future, the only direction we can see sea level move is up and toward the land, and everything in its path is vulnerable. Now, I'm going to say a little bit about California, but this has taken me longer than I thought, so I may not say very much. And Dan did a lot of this last time. Let me see what I got. So there's our beautiful state, San Francisco Bay. The least natural estuary that I am aware of, certainly in the United States, and one of the least natural in the world. It's about 20% smaller than it was before the gold rush, because gold was mined using hydraulic mining methods where you use high-powered hoses. It released sediment. The sediment moved down and filled a lot of the bay in. Will Travis, who will talk to you in the last night of this class, is the executive director of the BCDC, the Bay Conservation and Development Commission. He's an amazing person. We've been friends a long time. He's the first and only director of the BCDC. The BCDC was created because people kept filling in San Francisco Bay, but build houses closer to the water. And their mandate was, stop the filling, keep the bay the size it is. Now his big challenge is, how do I keep the darn bay from growing and getting bigger and invading everybody's house? Because of all of the coastline, San Francisco Bay is the most vulnerable. It's also very unnatural in terms of things that live there. You've all heard of non-native invasive alien species. In San Francisco Bay, over 90% of the biomass and 90% of the species are non-native. Some of them were brought in intentionally during the gold rush. Most of them were brought in unintentionally on the hulls of ships and in ballast water. And you could get very concerned and say, we've got to get rid of those. You've got about as much chance of getting rid of those as the Lakers had against. No, let's forget that. But San Francisco Bay is an amazingly beautiful, wonderful estuary. All right, so some important studies. This was the most important to date. Pacific Institute did it, and they looked at two scenarios, 1 meter and 1.4 meters. BCDC study, he'll talk about that. The National Research Council is doing a study of sea level rise in California, and it's underway, and it won't be done for another year. And I don't think it'll change most of it. Let me see if I missed one. No. We've got 2,000 miles of coastline, 800 along the ocean, and then we've got San Francisco Bay and some other embayments. It's very diverse in geology and geomorphology, that is in shape. And so you get a variable response. A lot of it is not very susceptible to flooding because we have tall, high cliffs, but it is to erosion. More than 26 million people lived in California coastal counties in 2000, and by 2003 it had gone up to 31 million, and 75% along the Pacific coast, that is the increase, 25%. So we've got a big, big population. And down here, between Point Conception and the Mexican border, we have 20 million people living along the coast. Amazing, beautiful, wonderful coastline, highly varied. And we do have places that have low-lying beaches. So places like this are susceptible to flooding. The other ones, earlier ones, are susceptible to erosion. This one's susceptible to flooding, not too far from here. They estimated that the 1.4 meter rise in sea level would put almost half a million people at risk in a 100-year event. What we're talking now, you read about the Mississippi, it's floods. Floods have a recurrence interval of 100 years. What does that mean? Larry?
The worst that's likely to happen in 100 years.
Well, almost. This is the other third thing you have to remember. Data are unique, and you take 100 and you divide it by the recurrence interval. So if it's a 100-year storm, then 100 by 100 is 1, and what it means is that during any single year, the probability of having a 100-year storm is 1%. And it's all about probability statistics, and it turns out that if you then ask, what's the probability of having a 100-year storm during a 100-year period, it's not 100%, but it's about 65%. And can you have two 100-year storms in successive years? The answer is yes, because these are just statistical measures. But if you made that happen, or if that were to happen, then you recalculate your statistics. The important thing with sea level rise is that what is now a 100-year storm by the middle of the century will be a 50-year storm. Now, what does that mean? That means that the probability of having that storm is twice what it is now. So that's why we have to be very concerned. Both the built and the natural environments are at risk, and we're particularly concerned about salt marshes. We've gotten rid of most of them, as I mentioned, and we have to be worried about this. If you're a salt marsh and sea level is rising, you have three choices. You build vertically to keep pace with the rising sea. That takes sediment. You move laterally ahead of the rising sea, which is what they've done for most of geologic time, or you die. You get drowned. Most of our estuary, most of our salt marshes are around San Francisco Bay. Do you think there are very many pathways, corridors for those salt marshes to migrate landward as sea level rises? No. And San Francisco Bay is one of the few estuaries in the world that is considered to be sediment starved. So if you're a wetland, you don't have enough sediment to build vertically, you don't have a pathway to move landward, it's going to be a tough time for wetlands. Have you heard of the South Bay Salt Pond project? You remember, if you fly into San Francisco, you look down and you see the Cargill salt ponds. A few years ago, the state of California spent $100 million acquiring some of those, and the idea was to convert them back into wetlands. And it was a good plan. And there were 4 of us that were asked to be on a national science panel. And we brought up this whole issue of sea level rise and that the $100 million might not be a good investment. The response was, they fired all of us. These are the 2 counties that are at greatest risk, San Mateo and Orange. Now, remember, the place that is at the greatest risk, San Francisco Bay. But on the open coast, far and away, San Mateo and Orange. And Orange County is going to be, in terms of property damage, it will be the worst. Your mansion on the beach, Corinne, sorry.
Fortunately, I don't live on the beach.
But the beach is coming to you, so your property value will go up. Maybe on the beach. So, anyway, they estimated $100 billion loss of property, $2,000, 2/3 of it would be around San Francisco Bay. Neither of the airports would be above sea level, the runways. Now again, I think we will protect those investments because there's so much invested. You can't abandon ports like we have out here. We're going to have to build structures. And I'm counting on the fact that we're in the lead of the ports and the aquarium is going to be protected, and that's why we're going forward with a $50 million expansion.
Your seawalls out of acrylic.
We expect that we've only got 350,000 acres of wetlands, remaining 25% are at risk. And I think we'll leave this one for it because Emily's getting nervous that I'm taking her time, right? Well, I'll talk to you though about, we put together a model for this workshop on what local communities can do to make better decisions. And maybe we'll do that sometime before this course is over. But let's stop for 2 minutes. Anybody have any questions or comments? And then we're going to move to the Ocean Science Center. Dave.
You mentioned that the 100-year storm event is becoming now a 50-year storm event.
Right, remember.
The probabilities are changing.
Yeah, because if you have the storm of the same magnitude now, on a higher sea level, its magnitude goes up.
Okay.
Okay, so
So it's not that the climate changing is increasing the likelihood of a storm,
No,
it's that sea level is rising, the dam.
Yeah. The frequency of storms, I think, is increasing, but that's a different part of it. It's quite different. Yes?
What was the name of the city that you showed that's relocating again?
Shishmaref in Alaska.
Okay.
Was that an island or a peninsula?
It's a peninsula. It's not an island, it's a peninsula. It will become an island.
Yeah. I just know.
Right. Yes?
The Pacific 2009 study, what was its name again? Yeah,
Did you get a set of notes? It's on.
oh, okay,
When-
yes, I did.
All right, it's there. You can get it online. It's a very good report. It's worth reading. Anybody else have a question or a comment? Bob?
You mentioned 1 foot rise equals everything given evenly, 100 feet inland.
Well, and it all depends on.
Yeah, I
Okay.
As an average basis.
I'm not sure there's a good average. We used to use what's called the Bruin rule, and it's fallen into disfavor. But I think in low-lying areas, like parts of along here, for every foot it goes up, it will advance laterally tens of feet to 100 feet or more, unless you put something there to stop it. But when you have a cliff, you know, so
It'll erode the cliff more.
it will erode the cliff, and we will see a lot of erosion over
More
the next,
patios and houses.
the next few decades. So off California, now remember when we talk about global rise of sea level, in the last 100 years, the estimate for California was 8 inches, last 100, 8 inches along the California coast. But for the last 20 years, almost nothing. And that was because of, as Dan explained, what's called the PDO, Pacific Decadal Oscillation. It's a combination of wind stress interacting with El Niños, La Niñas, and essentially you're pushing water away from the coast. But the belief now is, and he didn't say very much about it, one of his colleagues published a paper 2 weeks ago that said that we're now going into the different phase. Our waters will warm, and we can expect to see a faster rise in sea level along the California coast than the world global average because of that sloshing back. So it's a very dynamic.
Well, that's one of the problems. We live such a short period of time, and science as we know it has only been around a couple 100 years. Records data and stuff.
Right.
Satellite ability to measure the sea level rise through telemetry. I mean, all of this is in your 15 minutes.
That's right.
And yet we're trying to hit off effects that are going to affect generations.
No, that's
So
right.
running hard.
So we're going to have to be nimble, and in the literature, we have to create what are called resilient communities.
The problem is the politicians want the answers, and sometimes you have to start running. You know, the atomic bomb wasn't proved before we started building it. I mean, you got to get started.
You have to get started, and there's no better way to learn than by doing.
Yeah.
Now, some of you have heard of coastal and marine spatial planning. It's taking the designation of marine protected areas to a higher level where you now allocate parts of the ocean to human uses as well as to nature. And there are these efforts that have been going on for a couple of years in the state of California, defining the process. We announced that we're going to have, and it will be the first time ever that anybody has tried to do this in a particular location. We're going to do it in July. Sacramento, I got another call today saying, you can't do that. And I said, just watch. Because there's no better way nobody's asked us to do it, so that we have no status, and we're going to bring smart people together and see if we can essentially have a big board game and allocate uses. We could have a $1 billion aquaculture industry in 1% of state waters. 1%. If you go on your computer and make a 10 by 10, and it will 10 by 10, and you got one little square. Good jobs. Do you know how much? We have the largest ocean economy of any state in the country, and it's dominated by tourism and recreation. Now that's good, but do you know what the average paying job in the tourism industry was last year, for which we have data, which was $17,000 a year. Those are the people who make the beds and clean the hotel rooms and serve you in the restaurants. They can't make enough money to live anywhere near where they work. They drive tens of miles. The price of gas, they can't do it anymore. And we with our fish, seafood, Southern California, we import 80% of our seafood. 50% of it is farmed, 70% of that comes from Asia. At the last International Aquaculture Congress, last month, China, which was where the biggest supplier, China said soon, and by soon they meant the end of next year, China will be a net importer of seafood. Where will we get the seafood? You recommend it as being helpful. It is helpful for us to eat seafood. Either the price is going to go through the roof and only the people like us in this room will be able to afford it. We've got to get real about some of these issues, and if we know how to do these things, and I'm get very upset about this.
Really?
Andrew Revkin is a wonderful writer for the New York Times, and in his blog on April the 23rd, I think it was, he said the two phrases that have dominated our thinking in the environment in the last century have been, woe is me and shame on you. And he said, I plead guilty to having done that. But when I look ahead to the century we're in now, we've got to figure out a way to use our environment, not only to, we have to protect it, but we've got to let you help it, people make livings and so on. And they're not incompatible. That's really the challenge. So, all of the data would know. All right, Emily, lead us to our next destination.